All right, let's jump right in. We're about to unpack one of the most powerful ideas in all of programming. It's a concept that lets you write cleaner, more efficient code by, well, truly working smarter and not harder. We're talking about inheritance. You know that feeling, right? You're building something new, and you suddenly realize you're typing out the exact same code you wrote 5 minutes ago, just with one or two tiny little changes. It's frustrating, and it just feels inefficient. Well, guess what? There's a brilliant way to escape that loop.
So, to make this all crystal clear, let's ground it in a real-world example. Imagine we're building a simple software system to keep track of the inventory for a store.
Now, as we start building this thing, we're going to run smack into a very common trap. I call it the duplication problem. It's so easy to fall into, and it can turn a clean project into a total mess that's a nightmare to maintain. Okay, first things first. We need a basic blueprint for any item in our store. Let's call it generic item. It's super straightforward. It has a place for the item's name and its quantity. And of course, it has methods to set those values and print them out. Simple, effective, it's perfect for most things on the shelf. Right, but here's the curveball. Our simple class works great for things like cereal boxes or cans of soup. But what about apples or milk? Those things have expiration dates, and our generic item has no clue how to handle that. So what do we do now? We're basically at a fork in the road. On the left, we've got the inefficient way. We could just make a totally new, separate produce item class, then copy and paste everything from our generic item class, and then tack on the expiration date stuff. I mean, it'll work, but you end up with so much repeated code. But then there's the smart way. We just tell our program, hey, a produce item is just a special kind of generic item, and then we only have to write the tiny bit of new code we actually need. And you know what? That smarter way has a name. Inheritance. It's this core principle of building new things based on stuff that already exists. And let me tell you, it is a total game changer for keeping your code organized. This right here, this is the whole philosophy in a nutshell. Don't repeat yourself. DRY. It's a simple idea, but it's the absolute key to writing code that's easy to manage and build upon down the road. Okay, let's lock in two key terms so we're all on the same page. The original class, our generic item, we call that the base class. Think of it like the parent or the foundation. The new, more specialized class we made, produce item, is the derived class because it derives all its basic features from that base. So how do we actually tell the computer, hey, this class should inherit from that one? Well, it's actually surprisingly simple. It all comes down to one single, really powerful keyword. And here it is. This one little word extends. That's the magic spell. It's what forms the connection, telling the produce item that it is an extension of the generic item. It's how we say, hey, produce item, you're a special version of generic item, so you automatically get all of its powers. All right, theory is great, but let's see how this actually behaves when we run the code. This is where you'll really see the power of inheritance light up. So, check this out. First, we create our two items, a generic one for some cereal and our special produce item for some apples. Setting the cereal's info is no big deal, but look at step 3. For our apple, we call setName and setQuantity. But wait a minute, we never wrote those methods inside our produce item class. How can we use them? We can use them because it inherited them from generic item. That's the magic. We get to use all the old code plus our new code all in one clean package.
And that is the big aha moment. With that one little extends keyword, we wrote the setName code just one time in our base class, but now we can use it in all sorts of specialized classes. No copying, no pasting, just pure, beautiful reusability.
Now, let's zoom out a bit, because this idea is way bigger than just two classes. It's about creating an entire logical family tree for your whole program. Look at this. From our one little generic item base class, we can branch out everywhere. We can have our produce item over here, maybe a book item over there, but we can go even deeper. The produce item can become the base for a fruit item and a dairy item. The book item can split into textbook and audiobook. You see what's happening? We're not just writing code anymore, we're designing an organized family. Everything is connected, everything has its place. So let's wrap up with the 4 huge wins this gives us. First, code reusability. Write it once, use it 100 times. Second, less work. You only have to code what's actually different. Third, better organization. You get that clean, logical family tree. And maybe the most powerful of all, easier updates. If you find a bug in the generic item class and you fix it, every single class that extends it gets that fix instantly, automatically. That is coding smart. You know, this whole concept of building on a solid foundation, it's not just for code. It's really how innovation happens everywhere. So the last thing to think about is this. In your work, or even just in your life, what's a great existing idea that you could extend to create something totally new and powerful?